High above Colorado Springs in the Front Range of the Rockies stands a 9,565-foot citadel of solid granite. It's Cheyenne Mountain. Carved out of solid rock, a third of a mile below the surface in a man-made grid of chambers and tunnels designed to withstand a thermonuclear strike, is the Cheyenne Mountain Operations Center. Behind these hardened glass doors that weigh nearly 25 tons is a 4.5-acre subterranean compound that is the largest and most complex command and control center in the world. Over 1,200 men and women, including civilians, work in Cheyenne Mountain. The Cheyenne Mountain Complex was not only built for self-sufficiency and security, it was literally built to rock and roll. The 15 buildings that make up the complex sit atop hundreds of 3-foot-high steel springs. These 1,000-pound steel coils were designed to absorb the seismic shock waves of a thermonuclear strike or an earthquake. Since 1966, the mountain has been the operations center for NORAD, the North American Aerospace Defense Command. And since 1985, America's newest military service, the U.S. Space Command. NORAD continues to carry out a mission that began during the darkest days of the Cold War, when our national leaders feared the possibility of a surprise nuclear attack from the Soviet Union. NORAD's mission is the air sovereignty, aerospace warning, and aerospace control for North America. And since the Gulf War, Cheyenne Mountain's mission now includes the protection of American and Canadian forces around the world. General Howell Estes III is the Commander-in-Chief of NORAD and the U.S. Space Command. He believes that despite the end of the Cold War, NORAD's mission is as vital as ever.
We have a responsibility as a nation, as does Canada, because NORAD is in fact a binational command between ourselves and the Canadians, to provide for protection of the airspace over North America. That is a peacetime job. It would also be a job in crises. In peacetime, we call this protecting our air sovereignty.
Though relations between the U.S. and the former Soviet Union have arguably never been better, it is also a fact that Russia still possesses a tremendous nuclear arsenal and the means with which to deliver it.
And while at the moment we do not see a threat to our nation from the former Soviet Union, the capability still resides in Russia today. The intent clearly isn't there, but the capability is there. And so to ensure that we can protect ourselves against the possibility of some change there, which we do not contemplate, but nevertheless have to pay attention to, we need to keep the system in existence.
One of the men most responsible for the day-to-day support of NORAD is Major General Jeff Grime, the commander of the Cheyenne Mountain Operations Center.
A lot of people think there's a red button here and that we are the ones that push the button that would start the war. Let me assure you, there are no red buttons that do those sorts of things here. We are in the warning business, and we provide this information to our nation's leaders, who then make the determination as to whether or not we wish to respond in kind.
The U.S. Congress appropriated over $142 million to build the Cheyenne Mountain Complex back in 1961. It would probably cost $18 to $20 billion to build it today. However, some critics claim that maintaining this facility is too expensive and not necessary in a post-Cold War world.
They ask, is it not a relic of the Cold War? Is it not extremely expensive to be operating in the mountain? Actually, if you compare costs, the cost to operate in the mountain versus the cost to operate in a facility outside the mountain is very comparable.
NORAD's reach extends far beyond Cheyenne Mountain. It is connected to a global network of warning and communication satellites, radar systems, and deep space surveillance telescopes. NORAD receives information from all around the world, from Thule, Greenland to tiny Altera in the middle of the Pacific Ocean. Brigadier General David W. Bartram, Canadian Forces, is the Vice Commander of the Cheyenne Mountain Operations Center.
Cheyenne Mountain is a fusion center for data from air events, space events, and missile events. Information comes from the satellites in space for ballistic missile warning. Information from theater types of launches, like the Scud, is passed and detected by these same satellites and passed to Cheyenne Mountain. Information on air events around North America comes into Cheyenne Mountain. So in a nutshell, Cheyenne Mountain takes this information from this web of sensors around the world, located in space and air, on the ground and the sea, fuses that information and passes the information on to the National Command Authorities, the President of the United States, the Prime Minister of Canada, and to our warfighting commanders stationed around the world.
Despite NORAD's dependence on sophisticated satellites and other high-tech equipment, all data coming into the mountain is evaluated and verified by people. Unlike the movie War Games, there are no supercomputers here that can circumvent their masters. Lieutenant General L.W.F. Cuppins, Canadian Forces, is the Deputy Commander-in-Chief of NORAD, a position traditionally held by a Canadian.
What has made NORAD and our sister command, U.S. Space Command, so great, as I've observed since I've come down here, is the people that work in it. You can give everyone wonderful computers, the best of surveillance systems, the best of information, but you need to have that human in the loop, making sure that your product is 100% right. We cannot afford in NORAD to be wrong in our warning mission. The consequences are too great.
Though it is doubtful that the Cheyenne Mountain Complex would survive a direct hit by one of today's very accurate, high-yield nuclear warheads, it is still impervious to nearly every other weapon system and to any type of terrorist attack. The center has an air purification system designed to filter out nuclear, biological, and chemical contaminants. 6 big diesel generators to provide power and large stores of fuel, water, and food that enable it to be thoroughly self-sufficient for up to 30 days. In a crisis, the center may be completely sealed off from the outside world. The NORAD Command Center is supported by 6 other centers that are manned 24 hours a day. The centers are the Air Defense Operations Center, the Missile Warning Center, the Space Control Center, the Combined Intelligence Watch Center, the Systems Center, and the Weather Support Unit. Each has its own specific duties to help make it possible for NORAD to accomplish its mission. A mission first begun when America found itself in a Cold War. In August of 1949, an event took place in the Soviet Union that threatened the very existence of North America. The Russians had the bomb. Eventually, the growing Soviet military threat brought the U.S. and Canada together in a defensive partnership. In time, they would undertake what many believe is the greatest underground building project ever attempted. 22,300 miles above the Earth, the infrared sensor of a U.S. Defense Support Program satellite detects a heat source from a ballistic missile launch and transmits the data via high-speed processing sites to Durham, Saudi Arabia, and Cheyenne Mountain, Colorado. This triggers a quick alert response at NORAD.
Missile launch from southern Iraq.
So we have a missile event
from
alert,
southern
and
Iraq.
JTAG Joper reporting on a missile event out of southern Iraq.
Missile launch from southern Iraq.
This is CD CINCNORAD assessment on this event on the single SRBM is concerned.
During Desert Storm, the Missile Warning Center in Cheyenne Mountain detected the launch of all 74 Scud missiles fired at coalition forces by Iraq.
Predicted impact in Saudi Arabia.
Sir, we have an impact.
Predicted impact
Predicted impact
in
here
Saudi
is our
Arabia.
Khalid military city, Kuwait, Riyadh, and Saudi Arabia.
Thanks to NORAD, within 2.5 minutes of the launch, coalition troops are donning their protective gear and Patriot anti-missile batteries prepare to intercept the Scud. Though the Missile Warning Center was designed in the 1960s to detect the launch of Soviet intercontinental ballistic missiles against North America, the warning system was modified to also detect the launch of small, short-range theater ballistic missiles like the Scud anywhere in the world. It's an example of how the mission inside Cheyenne Mountain has evolved over the years. NORAD was created in 1957 to deal with the growing Soviet military threat. However, long before the communists came to power, the United States and Russia had fundamentally opposing philosophies. Russian civilization did not accept such basic Western concepts as democracy, individual rights, or the free market. Relations between the two countries became even more strained after the 1917 Bolshevik Revolution. But World War II would bring them together. By late 1941, fate would make the U.S. and the USSR uneasy allies. But this was strictly a marriage of convenience united by their mutual enmity of Hitler. American and Soviet forces combined to defeat Nazi Germany. When the war ended, it became apparent that Russian dictator Joseph Stalin had no intention of giving up the territory now occupied by Soviet troops across Eastern and Central Europe. By 1946, the possibility of armed conflict between the former Allies had escalated at flashpoints around the world. U.S. and Soviet troops, or their surrogates, confronted each other in places like Turkey, Greece, Iran, Manchuria, and Germany.
It was clear at that point that this uneasy alliance between the United States and the Soviet Union in the Second World War, and in fact with all the Allies, was falling apart.
In June of 1948, the Soviets flexed their muscles and tested the resolve of their former allies by closing road and rail access to West Berlin through East Germany. The U.S., the U.K., and France initiated the Berlin airlift to supply their troops and the people of West Berlin. Eventually, the blockade was lifted, but the Soviets had demonstrated a willingness to back up their rhetoric for communist world domination with bold action. They were also making big technological advances in weapon systems.
Just after the Berlin airlift, as we progressed in the early 50s, the Union of Soviet Socialist Republics started developing a significant bomber capability with the ability to drop gravity bombs on any of their targets. That was the technology of the day. And as that technology emerged, defense planners here in North America started looking at that threat and said, the logical flight path of it would be from that country over the top, through the north, over Canada, into the strategic targets in the heartland of North America, both Canada and the U.S. And they were worried because at that time there was not a defensive system for North America.
And once again, as a result of our experience in the Second World War, focus on air defense seemed logical. The American people were going to demand some sort of defense for the North American continent.
The primary responsibility for the air defense of the country was given to the newly formed U.S. Air Force. By the spring of 1949, they set up a makeshift early warning system in Alaska and the continental U.S. by linking 75 existing radar units together in a system nicknamed Lash-Up.
One of the significant factors in the continued development of and cooperation between Americans and Canadians in terms of air defense was occasioned by the growing sense of threat. Soviet technology now had grown by leaps and bounds.
If there was any doubt left that the USSR was a formidable adversary, this was removed after it was revealed that the Soviets had detonated an atomic bomb years before anyone had thought they would have the capability. The Russians were also developing new long-range jet bombers, which would have the capability of dropping A-bombs anywhere in the U.S. Defense planners in Washington now faced the problem of defending the continent from a nuclear attack. Obviously, the farther north enemy bombers could be detected and intercepted, the more likely they could be prevented from reaching their targets. This made Canadian cooperation essential to the success of any early warning air defense plan for North America. Fortunately, the U.S. and Canada had a tradition of working together on issues of mutual defense, going back to World War I. A joint U.S.-Canadian board studied the problem.
And the two nations, the thinkers of the time, both the political and military thinkers, started looking at the possibility of how would we defend North America, our homeland. And the idea came about that we could design an air defense system that involved detection, surveillance, and if necessary, intercept and destruction of such targets cooperatively. Basically, the premise is two could do it less expensively than one.
On June 1st, 1950, the first U.S.-Canada Emergency Air Defense Plan was approved by both nations. As a first step, Canada would make its northernmost territory available for a radar system that would have been cost prohibitive for them to build and staff on their own. This system would be nicknamed the DEW Line, for Distant Early Warning Line. The location of the line would be between the Arctic Circle and latitude 70 degrees north. This would provide the U.S. and Canada with the earliest possible warning of a Soviet attack.
The stations were numerous, the cost was very, very high, and of course the conditions under which these stations had to be placed were severe in the extreme. Canada, especially up north, can be inhospitable in the winter, and we're talking about temperatures that certainly would freeze exposed human skin and test the vacuum tube technology of the 1950s to the limit.
Despite tremendous hardships, the DEW Line did get built, and by 1961 extended from the tip of Alaska's Aleutian Islands to Greenland.
And basically what it was a tripwire system deployed in the high north of Canada along Alaska, along the coast of Labrador. And basically what it would do was it didn't really track objects, it merely was like a beam. A bomber would come and penetrate that beam and you knew something had passed. And then they relied on a series of radars further south in Canada called the Mid-Canada Line to guide interceptors.
In 1957, members of the U.S. Continental Air Defense Command and the Royal Canadian Air Force jointly recommended that the U.S. and Canada could best counter the growing Soviet military threat to North America by forming an integrated defensive system with a combined staff from both nations. The new organization would be called the North American Air Defense Command, or NORAD. On September 12, 1957, military leaders from both the U.S. and Canada celebrated the establishment of NORAD at Ant Air Force Base in Colorado Springs. However, their exultation was short-lived. Less than 3 weeks later, on October 4, 1957, the Soviets stunned the world by launching Sputnik, the world's first man-made satellite, into Earth orbit. In many places, the Soviets' great scientific achievement sparked talk of spaceships and moon travel. But to NORAD, it meant that it would just be a matter of time before the Soviet Union had the capability of lobbing nuclear weapons atop intercontinental missiles into a defenseless North America. The missile age required a whole new defensive strategy. But what should it be? In early 1958, the U.S. and Canada were still reeling from the implications of the Sputnik launch. The balance of world power had shifted to the Soviet Union. It would be just a matter of time before North America would be completely vulnerable to a ballistic missile attack. Originally, the U.S.-Canadian Air Defense Plan was to detect and intercept enemy bombers as far from their targets as possible. However, there was no way to intercept ICBMs. NORAD needed a new defensive strategy, and fast.
President Eisenhower had made it clear that our national defense policy would rest on a new doctrine, sometimes called the New Look, which basically emphasized the role of air forces and aerospace defense and long-range strategic bombardment to deter the Russians from attack.
Eisenhower's strategists came to the conclusion that despite the expenditure of billions of dollars, at a certain point the sheer number of nuclear weapons would overwhelm any sort of defensive system, including an anti-ballistic system. Therefore, they reasoned the best defense was a powerful offense. For the New Look strategy to work, it was essential that the President, the Prime Minister of Canada, and military command authorities be given the earliest possible warning that North America was under attack. If not, America's offensive strike force could be wiped out in a preemptive nuclear first strike. The idea was to deter a Soviet attack by preserving the U.S. capability for massive retaliation. It was around this time that NORAD's fundamental mission began to change from air defense to detection, assessment, and warning. Now, NORAD needed a radar system that could detect and track ballistic missiles to their targets. In early 1958, NORAD headquarters were located in a residential neighborhood in Colorado Springs in an old brick building on the grounds of Air Force Base. In addition to being much too small to manage the growing air defense system, the building was highly vulnerable to conventional attack or even sabotage, let alone a nuclear strike.
NORAD's Underground Combat Operations Center was a result of a number of factors, not the least of which was the perceived threat. When the Soviets exploded their hydrogen bomb and demonstrated a capability to marry that to long-range ballistic missiles, the secure command and control facility seemed essential.
The Air Force was given the somewhat incredible task of creating a hardened site, or an underground base from which the NORAD Combat Operations Center could survive and operate in after a nuclear attack. After a thorough study of potential sites, the Army Corps of Engineers recommended Cheyenne Mountain in the Front Range of the Rocky Mountains. Just 4 miles southwest of Colorado Springs, Cheyenne Mountain was near existing communication lines and supporting military installations. Most importantly, a geological examination indicated that the mountain's granite rock would offer the greatest degree of protection against a thermonuclear blast in the shortest possible construction time and at the lowest cost. The excavation and creation of the Cheyenne Mountain Complex would arguably be the greatest underground building project ever attempted. The Air Force design required a 253,000 square foot facility of freestanding buildings beneath 2,000 feet of solid granite. After an access road was built, the first phase of excavation began on June 20th, 1961, initiated by a ceremonial first blast. To give some idea of how desperate NORAD was to complete the new hardened center, they insisted that work be done in 3 shifts, 24 hours a day, 6 days a week, until the excavation was completed. Over 1,800,000 pounds of high explosives were used to blast the rock away. More than 693,000 tons of granite were excavated. It took only 367 days to do the job.
The excavation itself, the building of the tunnels within the mountain, was an extremely large project. It was run by the Army Corps of Engineers, and they did an exceptionally magnificent job in accomplishing that.
Great care was taken in order not to blast away more rock than the excavation design called for. An innovative blasting technique called smooth wall blasting was used during excavation to prevent excessive fracturing or weakening of the granite. To ensure that rock throughout the excavation would remain structurally sound, the walls of every cavern were reinforced with a system of rock bolts. Placed in a 4-foot pattern, these 6-foot to 32-foot long steel bolts hold the rock together and provide the tension to withstand the shock effects of a nuclear detonation. Chain-link mesh was then fastened to these rock bolts. The wire mesh prevents sprawling or the natural loosening of small rock fragments. More importantly, it would catch any rock shaken loose by a nuclear blast. There are 2 entrances into the mountain. The north portal leads to a 1,500-foot long tunnel, and the south portal runs for 2,500 feet. Both tunnels open into the central access tunnel, which is 1,000 feet long, 25 feet high, and 40 feet wide. The north and south tunnel entrances serve as air intakes, but more significantly, they were designed to allow a nuclear blast a way to pass through one end of the tunnel and out the other. The main complex is composed of 7 major chambers in a grid pattern. These chambers are 60.5 feet high and 56 feet wide. Phase 2, or the build-back phase of the project, began in early 1964. 11 buildings were constructed of continuously rolled 3/8-inch steel. Most of the buildings were 3 stories high. Each one was welded into a self-contained box to protect sensitive electronic equipment from the effects of an EMP, or electromagnetic pulse, that is generated during a nuclear blast. An airlock system was put in place to filter out the effects of nuclear, biological, or chemical contamination. Blast valves and doors were designed to prevent the effects of blast pressure and were designed to close automatically by sensing changes in the outside air pressure. All utility conduits were joined at key junctions in the flexible type of configuration which allows pipes and lines to easily sway without breaking in the event of a seismic shockwave. Every system in the mountain was also constructed with a triple redundancy, including power. With construction completed in early 1965, NORAD began the process of installing their computers, displays, and communications equipment into the new Subterranean Combat Control Center. Linking everything together and making it all work was not going to be easy, but military planners believed that our lives depended on it. The Soviet Union had already initiated the largest nuclear weapons buildup in history. In January of 1966, the new NORAD Combat Operations Center achieved its initial operating capability. Cheyenne Mountain had now become the all-knowing, all-seeing sentinel for North America.
Sir, we have an unknown. Quick alert. Proceeding.
Visual initiate.
Missile warning is showing a quick alert. The site appears to be...
Roger, understand. A launch from the Soviet Union.
Roger.
Sir, CINCNORAD assessment is required. Need a system report?
System report's valid.
Missile warning recommends a no assessment. This is a routine
Roger,
launch.
understand. Site report valid.
Over 30 years later, the new NORAD Command Center continues to evaluate quick alerts every time a missile is launched somewhere in the world. The Command Center is fed information from 6 other centers in and around Cheyenne Mountain. The System Center confirms that all communications and computer systems are operating correctly, so that what the people in the Command Center and other centers are seeing on their screens is accurate. NORAD's computers are all part of a closed-loop system that cannot be accessed by hackers. The Combined Intelligence Watch Center gathers intelligence information from other U.S. sources, including surveillance satellites, to assist the Command Center in correlating and analyzing events around the world. For example, they often warn the Command Center before a country is about to test a ballistic missile. The Weather Support Unit performs 2 valuable functions. They monitor geophysical and space weather elements such as solar flares that may affect the performance of the Defense Support Program warning satellites.
Now, our satellites in space will pick up that solar flare, and it could look like the launch of an ICBM or a submarine-launched ballistic missile. But our people are smart enough to know that before they would say that's an SLBM, they'll talk with intelligence to see if they have an understanding of where submarines may be. They'll talk with the weather people, who in this case would say, you have a solar flare that's glinting off of a calm ocean surface, and it may look like a missile launch.
The Weather Support Unit also continuously monitors the weather in North America. In some instances, the unit will confirm that severe weather could be the reason that a plane is not on a planned flight path and appears as an unknown. In 1981, NORAD's name changed, though its acronym stayed the same. NORAD's name was altered from North American Air Defense Command to North American Aerospace Defense Command to reflect its increased responsibility in the area of space surveillance and control. Since 1985, the U.S. Space Command has supported NORAD in these 2 missions:
The U.S. Space Command provides the DSP constellation. They provide the early warning radars, the ballistic warning radars, and the submarine-launched ballistic missile radars, plus a very elaborate intelligence system that is able to tap sources worldwide through other means that may be space-based to assist in confirming what these objects are. So without the U.S. Space Command, it would be impossible for NORAD to do that particular mission.
U.S. Space Command is a unified command composed of members of all of the U.S. Armed Forces. They also operate the Space Control Center in Cheyenne Mountain.
The primary mission of the Space Control Center is space surveillance. We're responsible for tracking all man-made objects that rotate around planet Earth. We've been doing this since 1957 when Russia put up Sputnik. That was catalog object number 1. The newest object that we're currently tracking on, some 40 years later, is object number 24,808, which is a Norwegian communication satellite.
Objects are tracked with both radar sensors and deep space electro-optical sensors that work much like a telescope. Incredibly, the near-Earth sensors can track objects the size of this bolt, 600 miles above the Earth.
On this display is the 24-satellite GPS constellation, which is a navigation constellation owned by the United States. Each of these satellites is indicated by a number, and the space trace is indicated by this line. And you can imagine what this would look like with 8,000 objects that we're currently tracking on.
The Space Control Center has supported every space shuttle mission by providing collision avoidance information to NASA. Ironically, the center now provides the same type of information to our former adversaries in Russia in support of the Mir space station. The Space Control Center is also responsible for re-entry assessments, or the prediction of when and where an object will re-enter the atmosphere. This is done for 2 reasons. First of all, the Space Control Center needs to have an up-to-date catalog of what is in space. The second reason is to comply with the 1971 Nuclear Risk Reduction Treaty between the U.S. and the former Soviet Union. If it appears that an object will re-enter over Russia, they are notified in advance so that they do not mistake it for an ICBM's warhead. The Missile Warning Center inside the Cheyenne Mountain Complex has an equally important mission. Their job is to report on space launches, strategic and missile launches, and nuclear detonations around the world. One of their most important tools is the DSP, or Defense Support Program satellite. These 2.5-ton satellites use infrared sensors to detect the heat signature of a ballistic missile during its boost phase. They are on station approximately 22,300 miles above the equator in a geostationary orbit and are spaced to provide overlapping coverage. Because they are traveling at the same speed as the rotating Earth, they essentially remain in the same location at all times, like ever-present electronic sentinels. In addition to the DSPs, the Missile Warning Center also utilizes the Ballistic Missile Early Warning System, which is built in the early 1960s. These 3 sites at Clear, Alaska, Thule, Greenland, and Fylingdales, England, provide overlapping coverage zones that extend over 2,600 miles into the Soviet Union's Arctic regions. 2 more sites on the east and west coasts of the U.S. provide coverage of the Atlantic and Pacific Oceans, respectively. They are on the lookout for sea-launched ballistic missiles, or SLBMs. This second independent system makes it possible to verify a missile event by a dual phenomenology method.
And by dual phenomenology, what we're talking about is using 2 different types of technologies, 2 different types of systems to confirm that, in fact, a missile event has occurred. For example, when the missile is first launched from wherever that may occur, it's going to be picked up by our Defense Support Program satellites. But before we would say that North America is under attack, we require a confirmation of that from our surveillance radars that we have around North America, hence the term dual phenomenology.
The Missile Warning Center is responsible for evaluating incoming missile event information and quickly passing it down the line.
So from the time a satellite picks up a launch worldwide, somebody processes that on the ground, sends it to us here in the Missile Warning Center. We inform the command center makes an assessment, and we inform National Command Authorities. Has to happen in under 4 minutes.
On average, the Missile Warning Center monitors over 200 missile events a year. The center is divided into theater and strategic missile sections. The Strategic Missile Warning System evaluates any launch that may be a threat to North America, while the theater section monitors areas where U.S., Canadian, or Allied forces may be at risk. If a missile can travel more than 2,100 nautical miles, it's considered a strategic weapon. The biggest difference between a strategic and a theater missile launch is the flight time. While an ICBM might require 30 minutes or more to go from one continent to another, a theater missile like the Scud might only be in the air for a few minutes. Therefore, theater commanders receive notification of a missile launch directly from DSB satellites. NORAD then provides additional details such as the time and location of an impact. The third major warning center that contributes to the NORAD mission is the Air Defense Operations Center. Once NORAD's principal component, their responsibility today is the command and control for the air surveillance and air defense network for North America. In 1989, the Air Defense Operations Center was asked to help win a new kind of war, one being fought in nearly every town and city in North America. Over 7,000 planes transit into North America every day, and every one must be accounted for. Most planes are identified by flight plan information provided by the FAA or Transport Canada. In an average year, there are approximately 800 cases that require NORAD's assistance before a positive ID can be made. In 10 to 15% of these events, the unknown aircraft are suspected narcotic smugglers. Since 1989, NORAD has joined the war against illegal drugs. NORAD takes no action against these planes itself. Their responsibility is to contact the appropriate law enforcement agencies and offer support. An incident in September of 1996 typifies the type of binational and interagency cooperation necessary to stop determined smugglers.
Initially, an aircraft was detected here in the Caribbean, and that aircraft could not be initially identified, and a contact was made with the customs folks to find out if they were interested in that aircraft as possibly being involved in drug smuggling. Customs expressed an interest in that, and we began to cooperate with them in sharing information.
NORAD's radar assets, in this case a Navy ship, allow them to pick up the unknown aircraft long before it would be in range of NORAD's land-based radar system. The U.S. Coast Guard then provided an airborne radar platform to track the suspicious plane until a Customs aircraft could take over. U.S. Customs Domestic Air Interdiction Coordinating Center asked NORAD's Canadian region to scramble 2 CF-18 interceptors to keep track of the suspicious craft as it approached Canada. U.S. Customs also notified the Royal Canadian Mounted Police, who joined the pursuit by helicopter. By the time the plane landed in Quebec, the bales of cocaine tossed from the plane had been retrieved and the smugglers were about to be arrested.
It's just a part of our mission here in NORAD. We want to identify, track, and if necessary, intercept every unknown aircraft that comes into NORAD. If they're bringing drugs in, then it's just a natural thing for us to detect them and pass them off to the law enforcement people to take the appropriate action.
Air Defense Command's job is more challenging today than ever. One of the reasons is due to the global proliferation of cruise missiles. They're fast, stealthy, low-flying missiles that could be armed with a nuclear warhead. They are very accurate and could be launched from a great distance by enemy ships or bombers. They are extremely difficult to detect because of their size.
Very, very small radar cross-section. So you have two challenges. One is to track the launching platform, and the second part is to track the missile itself. It's a technological challenge, and NORAD has been adapting to meet that challenge.
U.S. and Canadian leaders are quite concerned about the proliferation of cruise and ballistic missiles. NORAD's mission has become more daunting as production and sales of cruise missiles is expanding in foreign countries, and more than 30 nations already possess ballistic missiles.
And while today we don't anticipate a threat against our shores, in the future, as these missiles become more and more prevalent, not only to nations, but to terrorist groups, the risk to our country increases. We just need to think about this. I'm not saying we need to build a defense tomorrow. I'm just saying that's a job we have in NORAD to protect the borders of our country and the airspace above our nation and above Canada. And that's what NORAD's future is, worrying about ballistic missiles from rogue nations and worrying about the tremendous expansion and the proliferation of cruise missiles and the risk to our country from those cruise missiles. The time to start worrying about it and thinking about it is now, not after the first one lands on our soil.
Though the concept of mutually assured destruction helped deter war with the former Soviet Union, that kind of deterrent strategy would have little or no effect on terrorists. And there's always the worry of a missile being accidentally launched from somewhere.
Interestingly enough, I find that in discussions with people around the country, and we take surveys, we find that about 70% of our population in our country thinks that we have a missile defense system today. And the reason they think that is that they watched the Gulf War. They saw the Patriots firing against the Scud missiles. And so they naturally think that if we could protect forces in a place like Saudi Arabia, we can obviously protect our population. Well, protecting against those kinds of missiles as opposed to the kinds of missiles, the ballistic missiles that I'm talking about that would come over great distances and travel very fast, we're talking about a whole different kind of a capability here. And clearly, we do not have that capability in this nation today.
The U.S. government is currently studying the feasibility of creating an anti-ballistic missile defense system. If it is developed, most experts believe that it will probably be operated from Cheyenne Mountain, where its deployment would be supported by the assets of both NORAD and U.S. Space Command. Once again, NORAD's mission would be adapted to meet a new challenge.
I believe NORAD still has a valid mission in the post-Cold War world. The nature of the threat changes. The nature of the technology to meet that threat also changes, and NORAD has demonstrated over the last 40 years a clear capability to adapt its mission to new threats.
One of the main reasons why a sovereign nation fields the military is for protection of the homeland. And the things that we're doing in this mountain today are accomplishing those goals today, and they're just as important today as they were 10 years ago, and they'll be just as important 10 years from now.
There's no question that NORAD will continue to play an important role in the future. But as one walks through this subterranean maze, it's hard not to think of the past and a frightening era when the unthinkable was thinkable, and two mighty superpowers prepared for Armageddon. As one contemplates NORAD's significance, a truth emerges that is both simple and profound. We're all still here.